just Zoom 6.
A quick reminder, there's math and capital with Father Jones at 11:56.
And that will just give us a nice square screen, because we're going to be doing some graphing of weird things. So let's just go ahead. Everybody's got Zoom 6. We may have to change that. I don't know what's going to happen. We're going to graph number 5 on our calculator, and we're going to do this a couple of different ways. And then after we go through both ways with this problem, then after that you'll pick which way is your favorite. Because it really doesn't matter how you do it. Then you get the same answer either way. We are on number 5. This is 2.8, number 5, okay? Now, one strategy is to get everything set equal to 0. So add the 8x over, subtract the 2. So this is one strategy. All right? Then go to y equals and type in that equation. So y equals, and then type in x cubed minus 6x squared plus 8x minus 2, hit graph. Now, do you see something that looks like this?
Yeah.
Okay. Everybody knows that this point, and this point are the places where the equation equals 0, right? Your question was not only where does it equal 0, but where is it less than 0? So less than 0 would be this part of the picture and this part of the picture. Would everyone agree with that? So, first thing we need to do is figure out what these points are. So, remember how we do that? Second calc, 0. And then left bound, right bound, around the point you're looking for. I'll write down mine and you compare. I got 0.325 for that one. And 1.461 for that one. And yep, 4.214 for that one. Okay, we'll let everybody catch up here. How do those numbers look to everyone?
Good.
Okay, so now we have to write our answer. Well, our answer is everything we shaded. So we shaded from negative infinity to 0.325, bracket, because those dots are included. And then we shaded again from 1.461 to 4.214. And that would be my answer. How do you feel about that? Is that okay?
What's the other one?
I'm going to show you. All right, y'all good here? All right, the other way is to leave the problem exactly like it is. Type this in as one equation, and this in as a separate equation. So y equals, probably just try this with us. You're going to pick the way that's easiest for you. Typing in y1 and y2, two separate equations. Now, this is why I don't like this method as well sometimes. My picture is really unclear. you know what's happening, right? You've got a curve and you've got a line and they're crossing each other. But it's really hard for me to tell, so I'm gonna have to play with my window a little bit. Let's try that. I'm getting closer. Make one more adjustment here. Okay, I am still. It's something that does something like this. But I don't like this.
I don't like that method.
Well, it's a fine method, but
Seems
you
more
gotta,
complex now.
you really gotta mess around and figure out what.
The other one seems like less steps.
So anyway, if you use this method where you put in two equations, and sometimes that'll be fine. I think we did it on our last test. I think we plugged in two and looked what it cost. This is a little bit more complicated because there are actually 3 points of intersection, and you have to be able to see those clearly, and that's what I'm still messing around with, to see them. If you do it this way, and sometimes the picture will be beautiful, then just make sure you know which part of the graph you're looking at. We want the cubic curve, which is the squiggly one, to be under the line. So that would be this right here and this right here, right? So it's really the same amount of work because you still need to find these 3 points, but you won't find them with second calc 0, you'll find them with second calc intersect, right? And it's the x values you're looking for, and your answer is gonna have to be the same. All right, so doing however you want to do it, oh, actually, with number 6, it's already set equal to 0. So let's go ahead and do the first one in number 6.
Can we FOIL that out?
Don't FOIL it out. I mean, you can FOIL it out, but why would you? Your calculator will handle it.
Put the parentheses.
Just put in the parentheses, right, for the calculator. And if we are looking for where it is bigger than 0, then won't we be looking for parts of the curve that are up here? What do you notice? Isn't the whole thing up there?
Yeah.
There's nothing, it doesn't cross, it never comes down. And so, what does that mean? Negative infinity to infinity, that's exactly right. The whole thing is above the x-axis. And you may have known, hopefully thought about that happening, because in this problem, we are multiplying a squared and a squared. Won't those be positive and positive? So of course we're going to get positive. All right, same one, less than or equal to 0. What's the answer to that part of the problem? No solution. Empty set. It is never underneath. The whole thing's above. The whole thing's positive. Okay? Now, put the calculators down. The next one we're doing by hand.
Dang it.
We can check our answer with the calculator, but we're gonna do this one by hand, so here we go. Now, I want, Jaden, I need everybody listening to what I'm about to say, because I would bet my paycheck that one of you is gonna try to shortcut this problem, and it isn't gonna work, it never works, you can't do it, but you're gonna try to do it because you're not listening to me right now. When you look at this problem, I completely understand that your gut feeling is to do this. Isn't that what you're kind of thinking, is what I'm gonna do here?
No, I'm thinking of
I hope you're not thinking that,
No, I'm not.
because you can't.
I wasn't thinking that.
That will work, that will work in an equals, that is exactly what you would do in an equation. But if it is an inequality, can you tell me why that is illegal? That will get you no credit, that'll get you a big old X, I'll probably write, over to the side. Why can't you do this? Well, what's the difference? Why does that matter? When you were a little child and you first started working with inequalities, you learned that you could do the same thing to equations as inequalities. I mean, you can add 5 to both sides, right? You can divide both sides by 3. What is the one thing that's different about inequalities?
Negative sign.
If you multiply or divide by a negative, you have to switch the sign, right? If you are multiplying by x minus 3, could x minus 3 be positive? Yeah. But could x minus 3 also be negative? Yeah. So you can't multiply because you don't know what to do with that sign. So here is the process we go through. Get 0. So move the 4 over to the other side. Then get yourself a common denominator. So I move the 4 over, and then I multiply, that's like 4 over 1. So I multiply the top and the bottom by x minus 3. Now they both have the same denominator. The numerator is this. So my common denominator, move the 4 over, multiply top and bottom there by x minus 3 so that I could have one fraction, one denominator. And now I have that on the top. So let's clean that up. What is that?
Negative 3 is
X plus 1 minus 4x plus 12. Which Elijah, you said negative 3x plus 13. Good. Draw yourself a number line. It's going to be 2 dots on that number line. One of the dots will be at 3. The other one is a little harder for me to eyeball. Some of you can see where it's at, some of you can't. So if you can't tell, just over to the side, set it equal to 0, and that will tell you where to put the dot. It's at 13/3. You did the same thing with this one, only you just did it in your head. It's at 3. We're finding the zeros of the top and the bottom. Now, 13/3 is bigger than 4,
Yeah.
right? So I'm gonna put my 3 here and my 13/3 here. Remember, this is a number line, so I gotta make sure I got it in order. And then I'm gonna pick a number like 0. And if I put 0 in, is it true? Is 13 over negative 3 less than 0?
No.
No.
Yes.
Yes.
Not true.
You said 3, not that.
We're in trouble.
Wait,
Negative.
it is
I think
negative.
you're-
13 over negative 3
Yeah.
would be a negative number.
Yeah.
And negatives are indeed less than 0. So, on my number line, out here is where 0 is. 0 made a true statement, so I'm gonna shade all this in. Wherever 0 is on the number line, it's gonna get shaded, cause 0 gave me what I wanted. If 0 worked, this is shaded, this will not be shaded, and this will be shaded. So the answer to the problem is negative infinity to 3 and 13/3 to infinity. All right? Well, now there's one you get to be by yourself, okay? Come on. Let's see what you can do with this one. First of all, 0's good. Don't think about doing anything that's gonna mess that up. Keep that 0. We want a 0 over there. Remember, that was our first step in this problem, was to get 0. So that part's good. What do you think we'll need to do? The common denominator. So, remember, the common denominator has to have both of these. So this one needs an x minus 1, and this one needs an x plus 3. Would you agree with that? So now we can write one fraction. Denominator is x plus 3, x minus 1, because now they match. And what's the numerator going to be? Well, 5x minus 5 plus 3x plus 9.
8x plus 4.
So 8x plus 4. Alright, we did that kind of fast, so how are we? Sam, you got it?
I got it.
Okay.
Alright, now.
So now I'm gonna draw my number line. And there are going to be how many dots on my number line? 3. And the dots will be where?
Negative 3.
Negative 3,
Negative 4.
positive 1,
Negative 1/2.
and yeah. So if you can do that in your head, great. If not, remember, solve it. And you get negative 1/2.
Keep it alive.
So negative 3, negative 1/2, and Dana?
I'm right here.
Okay, everybody good so far? Now what? Pick a number.
0.
Any number will work.
Negative
zero.
So
Negative 6.
the only numbers you can't pick are these. You can't pick those. Any other number? will
Negative
work.
5.
Negative 4.
Negative 5.
Yeah, I personally like 0. It makes my arithmetic so much easier. If I put 0 in,
4 over 2.
here's 0. My numerator will be positive. This will be positive and that will be negative. I don't even care what I get. I just need to know, is it less than 0 or not? So since 0 would give me positive over positive negative, that is less than 0, isn't it? So I'm going to shade where my 0 is.
So that means it's given.
That isn't, this is. So you guys that said I'm gonna pick negative 6, it should have worked for you. Negative 6 would work. So negative infinity and negative 3, and negative 1/2.
How do we know that negative 3?
Yeah, if you're all bothered by that, Dana, you can always pick a number, pick a number, pick a number, pick a number. That will always work for you too. But as long as there aren't any of those, as soon as I do that, gotta check every section.
So if there isn't power, then we just alternate.
You can literally choose any number.
Any number.
Because they have to work, all of them
It's
have
either
to
gonna
work.
work or not.
Oh yeah, all of them have to work, or all of them have to work.
You get a C.
One more comment about this problem, these last two problems. Right? Dana, stop. I'm gonna start calling that the talking chair, because Devon sits there and he just talks constantly also. Alright, let's suppose that the problem had been or equal to. Alright? If it had been or equal to, this is the answer to the problem on the paper, so this is what you'd have written down. But if it had been an or equal to, normally, what does that mean? Oh, that only means one thing, that means coloring the dots, right?
And then brackets.
In a, yeah, and then I'll have brackets in my answer. In a quotient problem though, a division problem, the denominator can never equal 0. So even if that were an or equal to, the negative 3 and the 1 would have to stay open. Do you see that? Because if you put a 1 in there, that's going to give you a 0 in the bottom and you can't do it. So if that had been an or equal to, the only dot that would be colored in is the negative 1/2. Dots that come out of the denominator are open. Period, always, forever. If it's a dot from the denominator, it's open. No matter what. Because denominators can never equal 0. So the only thing that would change is this guy would become a bracket. All right, here we go. Number 9, Dixie, make a box. Volume has to be at least 600 cubic inches. Squares are going to be cut out. This is our box problem. It's 20 by 25. Gotta cut the squares out. What size squares should we cut? We want the volume to be at least 600. Okay, so give me an equation. Length times width times height, which for this problem will be 25 minus 2x. 20 minus 2x times x. Hey, that's disrespectful. I know you don't mean to be disrespectful, right? Okay, let's not. Alright, do we remember doing box problems? We just did one back not a few days ago, it seems like. So 25 minus 2x, 20 minus 2x times x. That's it. Now when we did these before, we used our calculator, we typed that in, and we looked for the maximum, because that's what we were trying to do. We were trying to maximize the volume. This time we're saying we want this to be at least 600. So we are going to solve that on our calculator. Okay? Now this is a time when I think intersections are easier. Before you go to the calculator, I want you to stop and listen. What are your x's going to be? The domain of this problem is what to what? The only possible x's are 0 to 10. So when I set up my window, x min, x max, done. Now, the other equation, I need my volume to be at least 600. So my range, when I set up my y's, you can start at 0, that's fine, but you gotta go above 600, so maybe 800. And if you graph this as one equation and this as the other equation, you're gonna see what you need to see. All right, so let's do it. Set up your window, like I said.
For that second equation?
Second equation is just 600.
Just 600.
Yep, second equation is just 600. Make sure you're setting your window the way I told you. You won't have any issues, I promise. It'll be perfect. Did you see, kind of a hill thing and then a line across there?
Yep.
So this is your volume equation and this is 600. We want to know where are we greater than or equal to 600? So here's where we equal 600. And isn't this where we're greater than 600? So we're going to do second calc intersect. Find those 2 points. I got 1.659. $6.159. So what's the answer to the question? Bracket 1.659 to 6.159. That's my answer. When we did these problems before, our goal was to find the maximum. Do we care about the maximum this time? Yes. We just want it to be above that 600. All right, back at 45.
Thank you.